Krishnan, a final year electronics and communication engineering student from Government College of Engineering, Kannur. So I'll be presenting my internship project titled IoT based home automation system, and it's guided by Mrs. Jayalakshmi and Daniel and conducted under emertex technologies. Now about the internship was organized by emertex technology on IoT based home automation. The main goal is to provide hands-on experience with IoT, embedded system and programming. And we started with learning C and C++ for basic programming skills. Then we covered embedded system, how hardware and software work together. Learned about IoT concepts and implemented projects using Arduino and sensors. We used Arduino IDE, PixinLab and BlinkApp for coding and simulation. And our final project is smart home automation system, and it's controlled using a mobile app called Blink. Overall, it improved my technical knowledge and logical thinking and practical skills in IoT. Now coming to the timeline of internship, during the first week, we mainly focused on programming foundations like C and C++. We learned the basics of C programming like data types, number system, syntax. Practiced a lot of control statements and loops for logic building. Studied operator, arrays and jamming statement. Understood the functions and pointers with hands-on explanations. Explored advanced pointers and memory organizations. Learned about storage classes and preprocessor directives. We were introduced to C++ programming like classes, objects and constructors. Covered OOPS principle like inheritance, polymorphism and encapsulations. Now coming to the timeline of second week. During the second week, we were introduced to embedded systems and IoT fundamentals. We studied the Arduino architecture and used the Arduino IDE for coding. Practiced LED and LCD for interfacing using simulation tools. Worked with temperature sensors and display reading. We learned PWM for controlling brightness and motor speed. Implemented serial communication for data transfer. Integrated with the Blink IoT app with Arduino. And we gained practical understanding of hardware and software connections. And during the last 2 weeks, that is the week 3 and week 4, we focused on our final year project, which was IoT based automation. And we planned the circuit connections and component requirements. Programmed the Arduino for device control and automation. Used BlinkApp for smartphone based monitoring and switching. Tested system using PixinLab simulator before final setup. Integrated the LED sensors and other devices into one system. We focused on improving accuracy, response time and reliability. And we completed the IoT home automation system successfully. Now coming to what we learned. So during this 1 month of internship, we learned the basics of C programming and C++ programming. We were introduced to IoT and embedded system, Arduino IDE, PixinLab simulators, and we learned some basic things required for our project like LED controlling using LDR, interfacing CLC, etc. Blink IoT integration, interfacing in the serial tank. Now the topics that we covered in the C programming, the fundamentals of C and its application, number systems, data types, conditional statements, operators, arrays, pointers, functions, storage classes, etc. Now coming to IoT. IoT or Internet of Things is a network of physical objects, things embedded with sensors, software and other technologies that connect and extend data with other devices and systems over the internet. So it's not just a connection with the internet. In IoT, the data has also to be exchanged within the devices. So coming to the applications of IoT, the applications of smart home automation, used for controlling lights and fan using our mobile. Smart agriculture for monitoring soil moisture and automation of irrigation. In healthcare field for more monitoring the patient. Industrial IoT for maintaining the machines, and in smart cities for controlling the traffic light. Coming to the embedded system. An embedded system is a microcontroller or microprocessor based system designed to perform a specific dedicated task. Examples are washing machine, ATM, smartwatch, airbag, etc. So the main components, coming to the hardware, microcontroller, memory, sensor, actuator, etc. Input ports and software, the embedded firmware, RTOS, application code, characteristics, task specific operation, real time performance, low power and cost compact and reliable. Coming to the types, there are different types of embedded systems: small scale like remote controls, medium scale like smart applications, and complex like automated system. Now coming to the application, the automobile, engine control, airbag, medical, monitoring system, industrial, robotics, automation, consumer, TV, etc., cameras, etc. Now we use Arduino IDE for writing the code. So you can see the interface of Arduino IDE. So it contains a text editor for writing a code, a message area, text and console, a toolbar within buttons for common functions and series of menus. It connects to the Arduino hardware to upload programs and communicate with them. Now PixSimLab. So PixSimLab is a real-time emulator for development boards with integrated MPLABX debugger. The simulator which we use to implement the project programs in our project is PixSimLab. So we upload our program in the format of .x file in the PixSimLab simulator and we run it. Coming to our final project, so basically we made three sub project and then integrated all together to one final system. So the first one was LED based system where the light was controlled with the blink app. So the LTA's resistance changes with light's intensity. So when during the daytime when the light is high, the LTR resistance is low and the LED will be off, and during low light the LTR resistance is high and LED will be on. Coming to the second part of the project, that is temperature control system. So you can see in the block diagram there is Arduino, CD, temperature system and Blink IoT app. So it's used for manually controlling cooler and heater via Blink app. So if the temperature rises above 35 degrees Celsius, the heater will automatically turn off, and if it's below, it will turn on. Like we can turn on manually. The notification will be sent to the Blink app. Now coming to the third part, that is water tank control. So here we manually control inlet and outlet valve via Blink app. So if the water level falls below 2000 liters, the inlet valve automatically turns on. And automation rule, like if the water level reaches 3000 liters, the inlet valve automatically turns off. The notification will be sent for all tank. Now coming to the Blink IoT mobile app. So it's a platform to control and monitor IoT devices through a smartphone. It connects hardware like Arduino to the internet easily using a mobile app. Provides a drag and drop interface for creating custom dashboards. Uses authentication token to link or app with the microcontroller code. Supports various features such as button sliders, graph, etc. Allows a real-time data monitoring. Enables remote control of devices like lights, fan, or sensors. Compatible with Android and iOS. It helps in building complete iOS system without needing the complex web programming. Now coming to the project demo. So here you can see we have made several files, which has code of devices like LED and other devices, and we integrated in a final file called Blink Home Automation Blink Control. So you can see the preprocessor directives, and we use coder VP, heater VP, and update temperature reading. And in this code basically, for temperature part, Like if it reaches the temperature and if it's below 35 degrees Celsius, the cooler will be turning on, or else it will be off. Now coming to the water control volume, if it's below 2000 liter of water, then the inlet valve will be on, or else it will be off. And at a maximum of 3000 liter, it has a capability of maximum of 3000 liter. Now this is the code of LDR part, the main part of the code where we have given defined the pins of each part, the serial tank part, and the temperature system. This is the function that we use for calculating the temperature. So here you can see in the Pixin Lab simulator. So we have the Arduino Uno over here, and here is the LTR sensor, and the temperature system over here, and LED here, and the Ethernet W5500 and the LCD display. So here you can see when the value of LDR is high, the LED is turned on, and when it's made low, you can see the LED is turned off. So basically during the night time we want LED to be turned on, and during the daytime the LED to be turned off. So when the value is low, the LED will be turned off, and when the LED value is high, meaning that it's day, so it's night, then the LED will be turned on. Now coming to this is the first project. Now coming to the temperature system. So here we have the blink gap. So you can see now it's showing 27.34 degree, which is the normal temperature, and when the heater is turned on, you can see that the temperature is increasing. It goes from 30 to 31 and 32. You can see when the cooler is turned on, you can see the fan is rotating and the temperature is decreasing. Now coming to the third part, which is tank controlling, water tank controlling. So for that we have a serial remote tank over here. So you can see that the tank is full right now. So when I am pressing the inlet valve to on, you can see that since it's full. Now when I'm pressing off, when I'm turning on the outlet valve, you can see the water is getting out of the tank and it's decreasing. When the inlet valve is on, the tank is being filled to its maximum. Okay. Now coming to the overall feedback and conclusion. The internship gave a strong foundation in C and C++, embedded system and IoT, helped to gain both theoretical knowledge and practical experience, improved skills in coding, circuit design and debugging. We learned to work with Arduino sensors and Blink IoT platform. It enhanced my technical knowledge both in C and C++ and also, related to IoT. It enhanced my problem solving skill, teamwork and project planning. Build my confidence to design and implement a real-world IoT application, and overall is a valuable learning journey towards becoming a skilled IoT and embedded system. Once again, I thank emertex crew for giving me the opportunity to be a part of the internship program. Thank you.